Good morning, guys. We will continue what we have talked about previously. If you remember, in our previous class, we have talked about trees, and we have talked about our first part was about traversing, and we said that we have four methods or four ways to traverse: breadth first, which is level by level; we traverse the node level by level, if you remember. For example, if we have this tree, we will traverse it from this level: 8, 3, 10, 1, 6, 14, 4, 7, 13. Then we have talked about depth, weights, and we have mentioned that we have three ways to do the depth traversing. The first one is pre-order, which is start from the root, left, then right, and in order. The second one is in order, which starts from the left, root, then right. The third thing is the both order, which is start from left, right, then root. And we have mentioned that imagine that you are blind because the computer does not have eyes. You are blind and you will try to traverse these nodes. So you will apply the same steps recursively. So you are applying recursion. So when you reach to any node, you will ask yourself, which way should I use? Pre-order, in order, or post-order? And I should follow the steps. For example, if I am in the pre-order, first of all, I will visit the root, then left, then right. In every node I reach, I should visit the root, then left, then right. In the in order, when I reach to any node or when I arrive to any node, I should first feed the left, then the root, then the right. In the in order. In the both order, I should apply also the same steps. First of all, I should first the left, then the right, then the root. This is the most important points in our previous lecture. Inshallah, today we are going to talk about another operation. We have talked about traversing. Today, inshallah, we are going to talk about searching, insertion, and also we are going to talk about deleting. Okay, so this is what we are going to talk about in the second part of the trees: searching. Then we are going to talk about again insertion, how to insert node to binary tree. And also we are going to talk about deleting. Okay, so please listen to this video carefully and focus on what I am going to talk about. Now we will start with the binary search. Binary search tree structure used for searching. The following are some of the properties of BST. Every node in order by some key data feed. So the nodes in this binary tree or binary search tree are ordered. As you can see here, the most left node is the minimum or the smallest, and the most right node is the largest, if you can see here. For every node in the tree, its key is greater than its left child's key. So always the left child key, this is the key, is less than the right. As you can see here, 3 is less than 10, 1 is less than 6. Also, for example, 6 is less than 8, 8 is less than 10, 10 is less than 14, as you can see here. So always all the nodes on the right are less, on the left are less than the keys on the right. This is the second thing. So the first thing, these are order, as you can see. The second thing, always the right child's key is greater than the left child's key. Also, the BST is not allowed to store duplicate value. As you can see here, we cannot store duplicates value. So these are keys. Mainly these techniques used for searching and sorting. Searching and sorting. So when we want to do a searching process and we want to optimize our searching process, we have to make sure that all the nodes contain keys, not duplicate value. And the same for sorting. So to optimize our searching and sorting process, we have to make sure that these are key and they are not duplicated. So now I will go to next slide. Okay. BSC operation insertion. As you can see here, for insertion, adding a new node binary tree can be divided into 2 stages. Search for a place to put a new element, insert a new element. So of course, if you want to insert any value, we have to search for where to put this element, the place, and we have second is to insert the value. Now, please look at these rules for insertion. For BSC binary tree, binary search tree. So the rules is for insertion, first of all, I have to search. When I want to search, I want to find the place, I have to take in consideration, as I have mentioned here, these nodes. The keys are ordered. This is the left, the minimum value, and this is the largest value. The minimum value is the left, the largest value is on the right. Okay, no duplicate value. Always the left is child is less value than the right, and no, and these are ordered. Now, to do the insertion, of course, I'm going to do the insertion, the search process first, taking in consideration the 3 points that I have talked about. Ordered, left is less than right, and no duplication, no duplicated value in the tree. After that, I will do the insert a new element in the place. Now, for the insertion, I will check if the new value is equal the current value, then this is duplication, so I will not do the insertion. So when I want to insert, first of all, I have to search. If the node or the value or the key of this node is exist, I will not do the insertion, because in that case, the value will be duplicated and this is not allowed. Second of all, if the new value is less than the current, then go to the left subtree, else go to the right subtree. So I will check the value. If it is less than the current node that I am in, I will go to the left. If it is greater than the current node, I will go to the right. Following this simple rule, the algorithm reached a node which has no left and no right subtree. So I will continue doing the same process until I reach to the leaves. أوصل للleaves. So after that, I will do my insertion. Now, let's take a look at the next, this slide, the next slide. Now, initially a new node has no children. First of all, this is our first case. If the new node has no children, now I'm going to insert a node here. So it is a leaf, okay? So our first case is I am going to insert a node, okay, in the leaf. Red circle indicate possible places for a new node. As you can see here, these are leaves, هذه leaves, هذه leaves, هذه leaves. Now I can either insert on the left or on the right, as you can see here and here and here. So I will insert in the leaf. This is our insertion here. I will insert. Now let's go to next slide. For example, I'm going to insert 4. So I will do my search here. I will search for 4. Now, is 4 less than 5 or greater than 5? It is less, so I will go based on the algorithm. I will go to the left. Now I will check again. Is 4 is less than 2 or greater than 2? It is greater than 2. So I will go to the right. Step 1, or this is second step. Now I will check. Is 3 is greater or less than 4? It is 4 is greater than 3. So the node that I'm going to insert is greater than 3. So I will insert it here on the right. So 4 will be here. As you can see in the slide, I am comparing now. As you can see here, 4 is inserted on the right of 3. So these are the steps that I have mentioned before. I am comparing 4 here with 5, so it is less, I will go here. Now I will compare 4 with 2, so I will 4 is greater, then I will go to 3. Now I will also compare 4 with 3, so 4 is greater than 3, so I will insert it on the right. So I will do the insertion after I reach to the leaf, and every time I will just check if it is on the end. I will check if the node is not null, okay, and has children. So I will compare between it and the inserted node. If the inserted node has less value, I will go to left. If it is larger, I will go to the right. Then I will compare. As you can see here, 4. I will go there. Then I will go here. Then I will compare it with 3 and put it in, or insert it here. Okay. So I will do that until I reach to the leaf. Until I reach to the leaf. So the insertion will be based on the value or depending on the key value. Now let's do some insertion quickly just to make sure that we are on the same page together. Now I am checking 19. Is 19 less than 5 or greater? No, it's greater. So I will go to 18 here. Okay. Now is 19 less or greater? It is greater. So I will put it here. Okay. The second thing is, for example, -2. -2. I will check. Is -2 less than 2 than 5? No. Yes, it is less than 5. This is the current node that I want to insert. It is less than 5. Yes, so I will go to the left. Then this is not null. I will compare it with -2 with 2. Is it less than? Yes, I will go here. Now I will compare -2 with -4. It is greater than, then I will insert -2 here. So I think this is easy and clear for all of you. But be careful guys when you try to, for example, insert 6, 18, for example. You cannot insert it, right? Because it is here duplicated. So in that case, this value is duplicated and you cannot insert it to the tree. 18. So I think this is easy for all of you. Now I will go to the algorithm here. It is just kind of flow chart. So this will help you somehow to understand the insertion process. Now let us check. Of course, first of all, we will not forget that, as I have mentioned a lot, when you do the insertion, first of all, you have to create your node. This is the key value, this is the value, this is the left node pointer, and this is the right pointer. This is the left, this is the right, this is the value, and this is the key. Now, in every insertion, of course, I am going to increase the size. Don't forget that. Okay, now I will do my insertion. I will check. If the list is empty, in that case, خلاص, the root is the new node. So if I am going to insert this new node to the tree, and there's no tree, so the root will be my new node. So this is the new node, and it is the root. Okay, this is our first case. Insertion. Now, if it is not empty, no, I will start from the root. So supposing that the tree is not empty, our first case is empty. In that case, again, I will just check if it is empty. I will consider this is the new node, the new node is the root. Now, our second case, no, if it is not empty, so I will consider that the current is the root. This is the root node, and it is the current. This is the root one. Now the current is the root, so the current is at the top of the tree. Supposing that we have nodes, that the tree is not empty. Now I will also consider that the current also is the parent now. So I will depend on this parent a lot. This is the root, first of all. After that, I will consider the root is the current is the parent. So now the root is the current. Now this is the current, and the current is the parent. So also I will assume that this is the parent, because I am going to check his childs here, or his kids, okay? So to check his childs, I have to consider this is the parent. This is the parent. Now, if the key value equals the current value, dot value, for example, I am going to insert 5, okay? And the current value here is 5. In that case, I will not do the insertion process, okay? I will return, as you can see here, and exit my algorithm. Return, خلاص. No insertion, because in that case, the value will be duplicated. Other than that, I will check. So it is not duplicated, so I will check the value that I am going to insert. Is it less than current dot value? If yes, so I am going to consider that the current is the left. So now the current in that case will be here, is the left one. هذا صار الكرنت. This is the current. طيب. If the current equal null, إذا كان فعليا هو null, خلاص, nothing. So I have to put my new node on parent اللي هي هذه dot left. So the new node اللي هي بال5 هذه الN, I am going to put it. إن شاء الله ما ريكورد. والله العظيم إنه So again, guys, this is the node that I'm going to insert is 5, and here it is, if it is empty, sorry, there was some connection loss, so I'm going to compare 5 with 6. If for example is 5 is less than 6, so I'm going to go to the left here. So this is the current at the and this is also the parent. Now, if it is empty, as I have mentioned, it will be the root, and I will increase the size by 1. So the current will be the root if it is empty, and خلاص, return, enter. Now, if the key value is equal the current, that will show that it is duplicated value, and I will exit my function, and I will not do the insertion process. If it is not duplicated, I will check the key value. For example, I'm going to insert 5, and 5 is less than 6. So in that case, the current will be this one. So this will be the current now. Current equal current هذه الحالية dot left. So now the current will be here. I will change the color. Current will be here. If the current is equal null, خلاص, I will do my insertion. I will do my insertion. I have specified the pointer that the current is the current dot left, but for now I will check the value here. If it is null, so now I will put my new node هذه اللي هي الان وين في البيرنت هذا اللي هو كان الكرنت بناء based on the statement في البيرنت دوت ليفت. Now, if the current value, the third case, if the current value is the tree is not empty, and the current value, for example, 5 and here 4, the current value is greater. No, not less. It is greater than current value is greater than the node value. Supposing that this is 4 and this is 5. So now the value that I'm going to insert is greater than the current value. In that case, the current will be current dot right. So the current in that case not will point to the right. Again, I will check the current now. إذا الكرنت null, يعني no node is here, no and no node is here. In that case, parent dot right, this is the current 5, 4. Now the current will be current dot right. Current will point to the current dot right because the key here is greater. The key value is greater than the current one, which is 4. In that case, if the current not equal null, in that case parent dot right equal new node. Parent هذا هو البيرنت dot right equal new node, so the new node will be added here 5. Parent dot right, sorry, on the right here. Parent dot right, not on the left. This is the algorithm that we have talked about. So parent dot right equal new node, then I will break. Okay. And of course, I'm going to increase the size for both. And here, the size is incremented by 1 for this insertion and this insertion. Okay, and at the end, I will add the new node dot parent equal parent. Okay, and size equal size plus 1. Size equal size plus 1. So what we have done here in the last statement here, we have this is the node. Supposing that the key value here is again 6, this is 5. If it is empty, no, now 5 will be here. This is the first case. 5 will be the root. خلاص, this is the first case. If the current, if it is not empty, so this will be the current اللي هو الستة هذه اللي فيها number 6 will be the current, and the root and the parent. Now, if the key value is less, I will go to the left. If it is right, if it is greater, I will go to the right. Now, when I go to the left, I will check. If it is null, إذا كانت null, I will add it here. If it is not null, I will do the same process again here. Now, if the key value is greater, I will consider that the current equal current to right, and the current will point here. Now I will check the parent dot right. Sorry, I will check the current. If the current equal null, I will make sure that the new node added على الparent dot right. Parent dot right. Okay, and I will make sure that the parent at the end of this statement, when I add the new node, I will make sure that the new node dot parent, يعني new node هذه dot parent equal what? البيرنت هذا الأصلي. Okay, so I repeated the steps to make sure that this is clear for you. So when I add the node to the left or right, to the left or right here or on the right, in that case, I will, after adding or insertion the node here, I will make sure that the new node dot parent equal what? The parent. This one, which is the current, or which is the root, and what's the current. Just to update my tree. I hope this is clear to all of you. Now I will go to next slide.